Wow, you should all have calculators. Come on. 95% of 20.3. So 20.3 milliliters of 95% ethanol. So we're going to multiply that times 0.95 or 95%, and we're going to get how much ethanol is actually in there. 19.285, which let's just say that's about, because this is not really a rounding off because I haven't kept up with all the significant digits here, okay? Some of you messed up on your significant digits on the test too. Let's just say 19.3 milliliters of ETOH, or ethanol, okay? The ETOH means F, and OH is what I put on the end over here, okay? Ethanol. Got that? Just kind of a chemist's way of shorthanding it, all right? 19.3 milliliters. All right, now, the density of ethanol is not exactly 0.95, but it's close, okay? It's close. I can figure out I can do all this math and figure out how many moles there are in there. Okay, basically there's a way to do it. We'll get to it in this semester. We'll figure out exactly how many moles. All right? So we can figure out how many molecules there are using dimensional analysis. Okay? But just for the sake of this, let's say, just for us today, let's just say we have 25.0 moles of C2H6O. Okay? We're just going to say we got that much. Rather than do all the math right now, because we haven't gotten far enough on the semester for you to know how to do the math, it'll be near the end of the semester before you get that far, okay, to do all this. But we'll get further and further along, all right? Let's just say we got 25, just for today. Okay, got it? Just made up a number, all right? All right. We can use this information to figure out how much energy we produce. Okay? This is negative 1,366.8 kilojoules per mole. So using dimensional analysis, how would I set that up to calculate the amount of energy? Is there an equality statement somewhere implied in here? What is the equality statement implied in here? Okay? And that's only true for ethanol. Okay? That number doesn't apply to other chemicals, only to ethanol. Okay? So now that I've implied, or from this fraction here, I figured out what the equality statement is. Can you do the dimensional analysis to figure out how much energy was released? What do we do? What? You had to do this on the test twice. If you were successful in the test, what do? Starting amount is this. Put it over 1. Okay, good. Then what? Oh, why did I put 1 mole on the bottom? Well, it matches the units of measurement, right? That's the way I taught you to figure it out, guys. The moles go on the bottom because it matches what is in the top here, the units of measurement in the top here. Okay? And really, 1 mole is 1 mole of ethanol. Okay? And this is the amount of energy released from 1 mole. Okay? Got it? They're not really equal, but we can think of them as being equal here. Okay? This is really a molar energy ratio, not really a mole. Not an actual equality statement, but you can think of it that way for right now. All right? So the 1 mole, each mole of ethanol gives us or yields this much energy. Okay? Okay, do the math. Everybody do the math. Everybody practice. You need to practice. Now you have to, whenever you are doing conversions like this, you have to show me the equality statement. Got it? Why have you left the equality statements off? And you got your setup all wrong because you didn't follow the step-by-step process I gave you. Okay? We practiced it. I gave you notes for it. The step-by-step process. Find your starting amount. Starting amount goes over 1. Find what two things are equal. Or in this case, a kind of molar energy ratio. Okay? And from that equality statement then, build your conversion unit by putting one side on the top, one side on the bottom. What goes on the bottom has matching units and species with the starting amount. Okay? That's what I told you, right? We practiced it. Okay? All right. What do I need to do to simplify? Cancel out species and units. Very good. Okay, now we're ready to calculate. And we know that all we're going to have left are kilojoules, and that's a measurement of energy. Okay? How much energy? 170. Yep. 0 on the end. Okay? Kilojoules. All right. How many significant digits do I need? All right. Here's how you figure out how many significant digits you need. Okay? You got to remember this. A lot of you failed to do the rounding off at the end. Okay? You left it out entirely. Not good. You've got to round off every time. Or you got to make sure your significant digits are right every time. Okay? Rounding off is required when it needs to be done. Okay? All right. You look at the measured and calculated numbers. Are there any measured numbers here? Well, not really. We said you could say that's measured, but what we actually did was we took the amount of ethanol we had and we calculated moles. Okay, so this is really a calculated number. Okay, this is also a calculated number. You look this up. Now these big reference books, you look it up in. Where are my two reference books? Oh, I turn over my chair here. There they are. I guess the clean people want to hold the stuff. Move some stuff around. Okay? Big reference books like this. Okay? I got heat combustion for all kinds of things. Now, all right. So, both of these are calculated numbers. How are we going to figure out from those calculated numbers how many significant digits I need in my final answer? The one with the least amount. Okay? Which one has the least amount? 25.0. How many digits does it have that are significant? 3 that are significant. So how many digits do I need here? So where do I start underlining? At the 7. So the 7 and 0 are insignificant. I need to round off and get rid of that 7 and 0. So how do I do that? How do I get rid of the 7 and the 0? Huh? Put it after the decimal. Am I just going to write 372 kilojoules? Huh? Got to move the decimal. Is that what you meant? Okay. You got to move the decimal. All right. We got to move the decimal from right here to right here. Anytime you have to get rid of a digit in the ones place, you must write your answer in scientific notation. You can't just move the decimal 2 places. You have to write it in scientific notation, which means it has to go between the first and second non-zero digit. Okay, so that's negative 3.42. Then what do I write? We're not ready to do that yet. Yep, 1, 2, 3, 4. So 10 to the 4th kilojoules. That's how much energy would have been released from 25 moles of ethanol. Okay, got that? Any questions about that? Alrighty. That looks like a lot of energy, doesn't it? Not really a lot. I mean, we have a whole lot more energy coming into these lights up here in the daytime. But that's the way we measure it in chemistry. Got that? All right. You cool with that? So, this whole unit. By the way, I'm skipping some units. I'm jumping right to the end. This is actually not Unit 2. This is actually Unit 10. Okay? But the reason I'm doing that is because there's a lab I think you guys would like to do, and you'd probably rather do it now than in December. Okay? Because the lab involves making ice cream. This unit, Unit 10, is about thermochemistry. Unit 10 is about thermochemistry, which means energy and chemistry. Okay? This lab is about, this whole unit is about thermochemistry. It's about the energy that's involved in chemical reactions. And I don't really want to make ice cream in December, do you? So I'm moving this whole unit up to here so we can make ice cream and enjoy it. Is that cool? But you're going to have to do some math to get there, which is the reason for doing that homework, because that math looks like the homework. Okay? So let me stop this video for right now.